What's up, guys? Mr. Hausman here. Today we are going to be talking about Pascal's triangle and binomial expansion. Right, so what is Pascal's triangle? It's pretty much just a shortcut that we can use to um, kind of figure out binomial expansions a little bit faster. Right, for example, if we had something like x plus 2 all raised to the 8th power, right, that can take a whole lot of time to kind of FOIL out, right? But Pascal's triangle gives us a nice little shortcut that we can use in order to determine the coefficients and what the exponents are going to be and everything like that. So let's go ahead and get started, right? So let's rewrite the following polynomials in expanded form, then multiply the expanded form to obtain a polynomial expression without parentheses. So in number 1 here, the expanded form would just be a plus b, right? Because we just have this a plus b all raised to the first power, which just means it's just a plus b. So the standard form would still just be a plus b. All right, well, what about 2? In 2, we have a plus b all squared. So in the expanded form, we would have a plus b times a plus b. All right, well, we can FOIL that out, and we can see, okay, well, it's going to be a squared plus 2ab plus b squared. And to help you guys out, what I want to mention, and this will come in handy later, so these still have coefficients, right? So we can say this is 1a squared plus 2ab plus 1b squared. All right, and I'll show you why in just a minute. All right, but let's go ahead and look at number 3. This is a plus b cubed. So we would have a plus b times a plus b times a plus b. Right, so if we wanted to FOIL this out, right, we would know we would kind of have to do it one at a time, right? So if I just look at these two, or really I can say any of them. Let's say we would leave it as a plus b. We can FOIL out the other two, and we would get a squared plus 2ab plus b squared. Right, then what we can do is distribute these into our expression there, right? And we end up getting that it's a cubed plus 2a squared b, all right, because we're doing a times a squared, a times 2ab. Then we're going to have to do a times b squared, and we get ab squared. That's going to be plus b times a squared, so it's going to be a squared b, plus b times 2ab, so that'll be 2ab squared, plus b times b squared, so we have b cubed. Right, and we can clean that up, and I'll add the coefficients again. So we'll have 1 times a cubed plus 3 times a squared b plus 3 times ab squared plus 1b cubed. All right, so now what we're going to do is we're going to look at these and we're going to try to determine a pattern, right? So this table right here says the coefficients of these polynomials are written in the table below. Look for patterns in the table and complete the remaining row. Then use this table to answer the questions that follow. All right, so we can see in the first one, if we had a plus b all raised to the 0 power, well, anything raised to the 0 power is just 1. Right, so the coefficient would just be 1. Here we have 1 plus b all raised to the first power, which is what we have right here. Right, and again, we can kind of add these coefficients in, right? This is really 1a plus 1b. So the coefficients would be 1 and 1. And here we can see the coefficients are 1, 2, 1. So we have 1, 2, 1. And here we have 1, 3, 3, 1. So if we're trying to look for a pattern, what we can kind of notice is that first off, the left and right side, it's always going to be 1, and it's always going to be, there's always going to be an extra term whenever we increase the power by 1. So if this had 4 terms, then this one is going to have 5, right? So we can kind of write that in. We know there's going to be a 1 on each side. And now the question becomes, well, how do we get these middle numbers, right? But if we look, there is kind of a pattern that goes along with it. If we add 1 and 1 up, we get 2, right? Because 1 plus 1 is 2. And then here you can see, well, 1 plus 2 is 3. 1 plus 2 is 3. So if we kind of follow that pattern, we can say, okay, well, 1 plus 3, that's going to be 4. 3 plus 3 is going to be 6. And 3 plus 1, well, that's going to be 4. All right, and we can keep following this pattern to determine the coefficients of an expanded binomial. All right, so we know, again, it's going to start with 1 on the side. And then we're just going to add them up, right? 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. All right, and we can keep going. We know there's going to be a 1 on the sides. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 1 plus 5 is 6. All right, and then again, last one, there's going to be 1s on the end. 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. And 6 plus 1 is 7. Right, and we can kind of see more patterns too. Like, for instance, the coefficient is always the coefficient of the second term, right, and the second to last term. It's always going to be the same as the power, right? So if this is raised to the third power, then the second term is going to be 3. Or the second coefficient, I should say, is going to be 3. Right, so how did we find the numbers in the next row? Let's describe this process. Well, we knew that it's going to start and end with 1. With a 1. Right? And then for all the others, right, we found that if we added the numbers above it, we would get the coefficient, right? So we can say for all others, add the coefficients. Above it in the previous row. All right, so we found in question 3 that a plus b cubed is, well, we know that's that a cubed plus 2a squared b plus 2ab squared plus b cubed. Right, and in 5a, it's asking, well, what can you say about the sum of the exponents on each term? Well, if we look at the exponents, right, and we remember, if it doesn't have an exponent, it's assumed that the exponent is 1, right? Well, the sum of them, it always adds up to 3. So we could say the sum is always 3. And that's going to be true in every case, right? So if this was a plus b raised to the 5th power, the sum of the exponents would always be 5, right? And what else? What do we notice about the powers of a, the first term, and each term of the polynomial expression when written in descending order? Well, we can see it starts, right, with 3, then it goes down to 2, then it goes down to 1, And really, we can even say it goes down to 0, right? Because a to the 0 power would just be 1. So the powers of a, they descend from 3 to 0. Right? And notice it's kind of the opposite for b, right? B, it's starting with 0 because b to the 0 power is 1. Then it goes 1, 2, and 3. And again, that's going to be true in every single case. So we can kind of use what we know here to determine an expanded polynomial a little bit faster, right? So let's look at examples of that. All right, let's start applying what we're learning. Number 6, we want to expand x plus 2 all raised to the 4th power. So let's take a quick look at our triangle. So if I look at the triangle here, right, it's raised to the 4th power. So I know my coefficients are going to be 1, 4, 6, 4, and 1. So let's write that out. We know it's going to be 1, 4, 6, 4, and 1. All right, and then we know from the last thing we noticed, right, our a term, which is going to be x, it's going to start with x to the 4th power, right? And it's going to descend from 4 to 0. So this is going to be x cubed, this is going to be x squared, this is going to be x to the 1st power, and we'll even write in x to the 0 power, right? X to the 0 power. All right, now, well, what about our b term? Well, our b term in this case is 2. And if we remember, it just goes in the opposite order as the a term, right? So if this is x to the 4th, well, then we know we're going to have 2 to the 0 power, right? And it's going to increase by 1 each time. So it's going to be 2 to the 1st power, 2 to the 2nd power, 2 to the 3rd power, and eventually get to 2 to the 4th power. So what we did right here is we just found all of the terms in our expanded polynomial. Right? Our first one is just this x to the 4th, right? Because 1 times x to the 4th is x to the 4th, times 1, because remember that's just 1, would just leave us with x to the 4th. And that's going to be plus, here we have this 4 times 2, so we have 8x cubed. 6 times 4 will give us 24, so plus 24x squared, right? Plus, here we have 4 times 8, which is 32. And that's going to be to the x, or times x. And then plus 1 times 2 to the 4th, which is 16. Right, so notice how we didn't have to expand this and then FOIL it all together and distribute. What we're doing is we're using Pascal's triangle to quickly expand our polynomial, right? So let's look at number 7. Right, number 7, it's raised to the 5th power, which means it's going to follow our triangle. We're going to go to the 5th row, or really it's the 6th one, but we're going to go down to where we see that a plus b raised to the 5th power, and we can see, okay, well, my coefficients are going to have to be 1, 5, 10, 10, 5, and 1. All right, so our a term is x, so we can say x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then if we want to, we can write x to the 0, but let's just leave it because we know it's 1. Right, and then our y, our b term is negative y. Notice how it's a negative y this time, right? So, well, negative y to the 0 power, which is what would be here, that's just 1. Here we're going to have negative y to the 1. Here we're going to have negative y squared. Here we're going to have negative y cubed. And then here we're going to have negative y to the fourth power. And then here we're just going to have negative y to the fifth power. I know, sorry, I grouped them a little too close together. All right, but we know the first term then is just this x to the fifth. And that's going to be minus 5 times x to the fourth y, right, plus 10 x cubed y squared, right, because this is negative y squared, so negative times a negative just leaves us with a positive. And that's going to be minus 10 x squared y to the third. Because it's raised to the third power, it stays negative. And that's going to be plus 5 times x times y to the fourth minus y to the fifth. All right, so again, it's way faster than expanding it using the FOIL method and distributing, right? So let's look at number 8. 8, we have our a term is 2x, our b term is 1, and it's raised to the fourth power. So we're going to follow the same pattern as number 6, right? It's going to be 1, 4, 6, 4, and 1. Right, our first term here, 2x, well, that's going to start right here, 2x to the fourth. Right, and then it's going to descend. So this will be 2x to the third, 2x squared, 2x, and then 2x to the 0. But again, we don't have to write that because we know it's just 1. All right, now our b term is just 1, which works out really well, right? Because 1 to the 0 power is just 1. This would be technically 1 to the first power. This is 1 to the second power, 1 to the third power, and then 1 to the fourth power. But we know 1 to any power is just 1, right? So all we have to do is kind of ignore it and just figure out our coefficient based on this 2x. All right, well, 2x all raised to the fourth power is like 2 to the fourth times x to the fourth. So when we solve that out, we just get 16x to the fourth. And that's going to be plus 4 times 2 cubed times x cubed, which ends up being 32 x cubed, plus 6 times 2 squared times x squared, which is 24x squared, plus 4 times 2 times x, which is just 8x, and then plus 1 to the fourth power, which is, again, just 1. All right, so let's keep going. Number 9. We have x plus 3 all raised to the fifth power. We go to the row where we have that a plus b raised to the fifth power. We get that the coefficients are going to be 1, 5, 10, 10, 5, 1. Right, our a term is x, so we're just going to have x to the fifth, x to the fourth, x cubed, x squared, x to the 1, and then x to the 0, which is just 1. And here would be 3 to the 0, which is just times 1. So we can say this is going to be 3 to the first power times 3 to the second power times 3 to the third power times 3 to the fourth power times 3 to the fifth power. All right, so we just have to multiply that out. So our terms end up being x to the fifth plus 15x to the fourth plus 90x to the third plus 270x squared plus 405x plus 253. All right, good. And let's keep going. We got 2 left. Here we have 3x minus 2 all raised to the third power. So we go to the row where we have that a plus b to the third. We see that it's going to be 1, 3, 3, 1. Here we're going to have 3x cubed. Here we're going to have 3x squared. Here we're going to have 3x to the 1 power, and here we'll have 3x to the 0, which is just 1. Right, then we're going to have negative 2 to the first power, negative 2 squared, and then negative 2 to the third power. Right, so it starts with 3x cubed. Here we're going to have minus, we have that negative there. Oh, I'm sorry, not 3x cubed. It's 3 cubed, which is 27. Right, 27x cubed. Then we're going to have 3 times 3 squared times x squared times negative 2, which ends up being negative 54x squared. Then 3 times 3 times x times negative 2 squared, which is 36x. And then minus 8. Right, and the last one, here we're going to have to use the exponent rules a little bit, right? Because our a term is 3a squared, and our b term is negative 4b to the third power, right? But we know everything is raised to the third power, so we're going to have the same coefficients as before. We have 1, 3, 3, and 1. Right, so our a term is that 3a squared, so that's all raised to the third power here. 3a squared all raised to the second power, 3a squared all raised to the first power, and 3a squared to the 0, which is just 1. And our b term is this negative 4b cubed to the 0 power is just 1. Here we're going to have it just negative 4b cubed. Here we're going to have negative 4b cubed all raised to the second power. And here we're going to have negative 4b cubed all raised to the third power. All right, so using our exponent rules, we know when we have a power raised to a power, we just multiply the exponents together. All right, so this is going to be 1 times 3 raised to the third power, and then a to the 2 times 3. So it's going to end up being 27 a to the 6th power, plus 3 times 3 squared plus a to the 2 times 2. All right, so that ends up being negative, because we have this minus 4 here, 108 a to the 4 b cubed. Right, and we got the a to the 4th because it's 2 times 2. Then b cubed isn't being raised to a power, so we just leave it as b cubed. Right, so we'll have to clean that up a little bit. But this is going to be plus because we have a negative, but it's squared. So it's going to be 3 times 3 times negative 4 squared, which ends up being 144, times a squared. And then because we have this b cubed raised to the second power, it's going to be b to the 6th. Minus negative 4 raised to the third power is negative 64. And then b to the third raised to the third power ends up being b to the 9th. All right, so just to clean this part up a little bit, we have 27 a to the 6th minus 108 a to the 4th b cubed plus 144 a squared b to the 6th minus 64 b to the 9th. Awesome. Great job today, guys. If you have any questions, feel free to let me know.